we try to solve one numerical example using the Aitken's delta square method. So to save the time, in order to save the time, here we already write down the problem. Using the Aitken's delta square method, find the root of a fx equal x cube plus x square minus 1 equal 0. Find out here we try to find out a one root. So here how we find the solution. So first 3 point means x0, x1 and x2 we find with the help of a fixed point method. So to apply a fixed point method, there is a need to find out phi x and an initial value x0 from where we start our approximation, our iteration. So how we write a phi x? So what is the necessary condition? What is the theorem? As we discussed in a previous lecture, mod of a phi dash x is a less than 1 for the class interval containing the root alpha. So here suppose at x equal to 0, what is the value? At x equal 0, at x equal 0, at x equal 0, what is the value? Fx equal what? Fx equal minus 1. At x equal 1, at x equal 1, fx is a what? Fx is a plus 1. Fx is a plus 1. This one is a negative sign, and this one is a what? This one is a positive sign. This one is a negative sign and this one is a positive sign. What is the meaning of this one? Meaning of this one is there is one root lie between 0 and 1. Means one root lie between 0 and 1. Between 0 and 1. Now how we write the phi x? Suppose here we write a phi x like this one, means we write a phi x equal here, suppose we write a x cube plus x square minus 1 equal to 0. So x cube plus x square equal to 1. So here we write down this 1 plus x. If we take x square common here, then x square this become 1 plus x equal 1. So what is the value of x? Here you may write x equal 1 upon 1 plus x to power 1 by 2. So here be able to write x equal phi x in this form, phi x. Now there is a need to check for initial value between 0 to 1, this phi x is a correct choice or not. Means by choosing this phi x, either we able to converge to our actual root alpha which lie between 0 to 1 or not. So for this one we need to check what? We need to check mod of a phi dash x, is a less than 1 for all x belongs to 0, 1. Now, what is a phi x? Phi x is a 1 upon 1 plus x to power 1 by 2. 1 upon 1 plus x to power 1 by 2. So, if we erase out this one, now there is a need to check what is the value of phi dash x. Now phi dash x is a what? Phi dash x is what? Phi dash x equal minus 1 by 2 into 1 plus x to power minus 1 by 2 minus 1. So this become what? This become minus 1 by 2 into 1 upon 1 plus x to power 3 by 2. So this one is a value of a what? This one is a value of a phi dash x. Now what is the value of a phi dash 0? Mod of a phi dash 0. Now this one is a phi dash x. So what is the value of a mod of a phi dash x? phi dash x is a what? This one is a mod of a minus 1 by 2 into 1 upon 1 plus x2 power 3 by 2. Now, what is the value of a phi dash 0 in this class interval? In this class interval, what is the value of a phi dash 0? So, mod of a phi dash 0 equal what? This one is a minus 1 by 2. If we put x equal to 0 here, 1 to power 3 by 2. So, this one is a minus 1 by 2. So, this one is a less than 1. Less than 1. Similarly, what will happen at phi dash 1? Phi dash 1, mod of a phi dash 1. Mod of a phi dash 1. Mod of a phi dash 1, this one is a minus 1 by 2 into 1 upon 1 plus 1, 2 to the power 3 by 2. So, this one is again 1 by something and this one is again less than 1. So, what we conclude here? We conclude here mod of a phi dash 0 is a less than 1. Mod of a phi dash 1 is a less than 1. Since phi x is a what? Phi dash x is a what? Phi dash x is a decreasing function. So, the value will decrease from 0 to 1 but lie with but less than 1. Here the value decreases from 0 to 1 and phi dash x is also a continuous function. Phi dash x is also a continuous function and the value decreases from 0 to 1 but this one is a less than 1. So, we conclude that thus what we conclude that thus mod of a phi dash x is a less than 1 for all values of x belongs to 0, 1. All values of x belongs to 0, 1. So, what is the meaning of this one? Meaning of this one, be able to find out a phi x in a such a way mod of a phi dash x is a less than 1 for this class interval which contain our one exact root, one exact or approximate root. So, we may start from any initial value between 0 to 1. Now, what is the phi x? Now, phi x become phi x equal 1 upon 1 plus x2 power 1 by 2 and class interval is a what? 0 to 1. So, we may start from any values. Suppose x0 be the 0.75. We started from this value 0.75. So, x0 equals 0.75. We started from this value. So, what is the value of x1? Because iterative scheme of a fixed point method is a xn plus 1 equal phi xn. So, what is the value of if we put n equal to 0? So, this become what? This become x1. x1 equal what? x1 equal phi x 0 means x1 equal phi 0.75. 0.75. What is the value for this one? This one is a 1 upon 1 plus 0.75 1 by 2. So, here we already noted down the value of x1. What is the value of x1? Here we noted down the value of x1. Then again after getting the value of x1, what is the value of x1? Here we noted down the value of x1. This one is a 0.75593. 0.75593. So, this one is a what? x1 is a 0.75593. Again, how we find the value of x2? It's a very easy task. Now, x2 equal what? x2 equal phi x1 means a phi 0.75593. So, already we calculated the value of x1, x2, x3, x4, x5 and x6, and in order to save the time, here we noted down the values of x0, x1, x2, x3, x4, x5 and x6. This one is by the what? Fixed point method. Why? Fixed point method. Fixed point method. Fixed point method. fixed point method. As earlier we say that Aitken's delta square method only applicable if we have a three known values. Suppose with the help of a fixed point method we find the values of a x0, x1 and x2. So Aitken's delta square methods, what will happen in a Aitken's delta square methods? In a Aitken's delta square method, first we write a iterative scheme of a Aitken's delta square method, Aitken's delta square method. Here we write a method. So what is the iterative scheme? Xn plus 3 equal what? Xn minus del xn whole square divided by delta 2 xn. So in order to find out the first approximate value with the help of Aitken's delta square methods, suppose n equals 0, so this become x3 equal what? X0 minus delta x0 whole square divided by delta 2 x0. Second order forward difference. Now how we find the value of a del x0 and delta x0? What is the value of a x0? We have a value of a x0 that we obtain with the help of a fixed point method. So first of all we obtain the values of x0, x1 and x2 with the help of a fixed point method. So what is the value of x0? 0.75. What is the value of x1? x1 equal 0.75593. x2 equal 0.75465. So this one is a value of x. Here we find a delta x. Delta x means difference of these two. So difference of these two is a what? 0.00593. What is the difference of these two? This one is a larger, so 0.00. So this one is a 8, 2, and this one is a 5 minus 4. So this one is a 1. This one is a first order difference. What is the second order difference? Delta 2x. Here we find the difference of these two. The difference of these two is a minus sign, minus 0.00. If we add these two, this minus this, so this become 1, 8, 3, 11, 9, 2, 11, 2, and 5, 1, 6, and this one is a 7. So delta 2x is a minus 0.00721. So these are the values. Now what is the value of x0? x0 is this value. x0 is this value. Suppose here we consider this one is a value of x0. This one is a value of x0. Okay. This one is a value of x0 and this one is a value of delta x0. This one is a value of delta x0. This one is a value of delta x0. This one is a value of delta x, and this one is a value of delta 2x0. This one is a value of delta 2x0. Now here we put the values of x0, delta x0 and delta 2x0. So what is the value of x3? x3 become x0 be the 0.75. What will happen here? 0.75 minus delta x. Delta x with the delta x0 means 0.00593 whole square divided by what? Divided by 0. Delta 2x0 minus 0.00593 7 to 1. 7 to 1. If we simplify this one, then what is the value of x3? x3 equal already we calculated, we calculate this value. What is the value of this one? Value of this one is a 0.75 4877 0.754877. Just compare this result. This one is after the third iteration. This one is a value after third iteration. This one is a value after third iteration. Now what will happen here in a fixed point method? This value we able to obtain in a fourth iteration. If we closely observe this one, fourth iteration. If we perform the fixed point method only, not Aitken's delta square method, fixed point method, fixed point method, fixed point method, point method, fixed point method, fixed point method, then the accuracy that we obtain in a third iteration by Aitken's delta square method, same accuracy, same level of accuracy we obtain using the fixed point method in a fourth iteration. This means the number of iteration required for same level of accuracy in a Aitken's delta square method is less in comparison of a fixed point method. So this one is a way, this one is a one step to apply a Aitken delta square method. Then here again we will write the value of x0, x1, x2, x3, this value means x0 is this one, x1 is this one, x2 is this one, x3 is this one. In a next iteration, to find out the value of x4, to find out the value of x4, we use the x1, x2 and x3, these three values to find out the value of x4. Then maybe the accuracy that we obtain after a seventh iteration, same accuracy we obtain in a fourth iteration using the Aitken's delta square method. So in a next iteration we use the value of x1, x2 and x3, because in a next iteration what will happen? x4 become what? x4 become here, x4 become what? x4 become x1 minus delta x1 whole square divided by delta 2 x1, means second order forward difference of a x1 and first order forward difference of a x1. So here we obtain x0 is a what? 0.75, x1 is already given, x2 is already given, x3 is already given, means what is the values? Values is this one, 75593, 75593, 0.75593, 0.75, 0.75, what is the values? Values with 754,877, 754,877, and here 0.75465, 465. So then to find out here we find the value of a delta x, then we find the value of a delta square x. Here we find some values, here we find some values here and here. But in this iteration we use the values of a what? We use the values of a x1, we use the values of a x1, we use the values of a x1, we use the value of a x1, we use the value of a delta x1, we use the values of a delta 2 x1 in order to find out the value of a x4. So in a same way we proceed in a Aitken's delta square method in order to reduce the number of iteration. Obviously here number of iteration reduces because in a fixed point method the same level of accuracy we obtain in a fourth iteration, but using Aitken's delta square method we obtain the same level of accuracy in a third iteration. So what is the summary of Aitken's delta square method? Aitken's delta square method accelerate the rate of a convergence, means accelerate the rate of a convergence, especially in a fixed point method. The number of iteration required to achieve same level of accuracy in Aitken's delta square method in comparison of a fixed point method is less. So how we apply? First, with the help of a fixed point method, we find what? We find the values of a x0, x1 and x2. Then we find the value of a del x0, del 2x0, first order forward difference of a x0 and second order forward difference of a x0. Then write iterative scheme of a Aitken's delta square method and putting the values, then we find the value of a x3. Then again to find out the value of a x4, we apply the Aitken's delta square method on a x1, x2 and x3. We find the del x1, delta 2x1 and proceed in this way. Then we able to accelerate the rate of a convergence. To accelerate the rate of a convergence, meaning of this one is the less number of a iteration required to obtain same level of accuracy that we calculated in a fixed point iterative method, means a less number of iteration required in a Aitken's delta square method in comparison of a fixed point method. Thank you. Thank you for watching my lectures.